Hello everyone, I am Mehmet Arda Yıldırım from Bilkent Physics Department, and this is the video presentation for my Physics 102 laboratory project. My main objective was to construct a quantification model for the linearity disruptions of the electric field created between two parallel plates and study the change in this disruption quantity as the distance to the geometric central axis of the plates changes. In order to find the electric field created by a uniformly charged disk at a distance z from the center of the disk, we have to integrate over all infinitesimal charges. Evaluating the double integral over the disk and considering the case where the dimensions of the disk are much larger than the distance of the point, we get this formula, sigma over 2 epsilon 0. This approximation is accurate for the considered case. However, in real life, the electric field is subjected to what we call fringing effect. As it can be seen for the pink disks, the electric fields stray away from the linearity as it gets further away from the central axis. The task is to interpolate the field curves as polynomial functions and compute the average curvature value of curves. Here's a list of required equipment. In a plastic box, semolina seeds were sprinkled with a spatula onto the previously poured castor oil, and 3.50 kV voltage was applied to the plates. The seats near one end aligned along the electric fields. This photograph was taken and adjusted for better visibility. Then the adjusted photograph was uploaded to the Blender, in which I set up Cartesian coordinate system and got it ready for the measurements. The measurements were taken via the measure tool built in Blender by default. Since the grid on which I placed the photo is divided into equal squares, I had to measure the ordinate value at each endpoint of the squarely interval. The measurements were taken for 5 chosen curves independently. Once the data is collected, the curves were interpolated into polynomial functions using the NumPy library in Python. Here is the output of the code for each respective curve. The interpolated polynomials were plotted in Desmos, in which I also computed the average distance to the x-axis, curvature functions, and average values of the curvature functions. You can see the final results I got. It seems that the expected increasing trend can be observed except for curve 3, which accounts to errors. Because the experimental setup used is prone to errors, if more trials were run, the increasing trend was more likely to be observed with more accurate results. Nonetheless, these results show that the experiments once again verified the theory precisely. Thanks for listening.